Hello, my name is Greg Sifferlin with Schneider Electric. I'm the Cooling Business Development Specialist for the Northeast. Today we're in the cooling lab of our West Kingston facility to demonstrate the Uniflair room cooling units. Uniflair precision air conditioners are available in both upflow and downflow configurations. They're also available in heat rejection, chilled water with capacities up to 40 tons, air, water, glycol economizing units with capacities up to 30 tons. This particular unit is an energy-saving glycol economizing unit. It is downflow discharge and sits on an adjustable floor stand. All the Uniflair units have external double wall insulated panels to reduce sound power levels in the room. All the units carry a sound level, weighted sound level for the room of 62 decibels or less. On the front panel, we also have the LCD backlit operator display with both numeric and graphical icons and a lockable non-fuse disconnect switch. At this point, I will power the unit down so that we can access the internal components. I go to the operator display, hit the up arrow, hit enter to switch the unit off, follow the prompt and hit enter again. At this point, the compressors would pump down and the fan will come to a complete stop. Now that the unit has come to a complete stop, we can throw the non-fuse disconnect switch and open the outer panel. The panel for the operator display is hinged. All the other panels on the unit have spring clips. Just by simply pulling, we can remove the unit panel. Inside the unit is covered with internal panels for the electrical compartment and for the machinery compartment, as well as the airflow. In this case, for demonstration purposes, I've removed the internal panels for the machinery compartment and for the electrical. We've also replaced one of the airflow compartments and the high voltage side of the electrical panel with plexiglass for demonstration purposes. First, I'll talk about the standard features on the unit. The units are all equipped with MERV 7 filters. Standard also is a blue fin or hydrophilic coated coil. This coil improves fin longevity up to 3 times and also improves the drainage of condensate. Temperature humidity sensor is located within the airstream on the underside of the electrical panel. Standard also is the EC or electronically commutated blower. This blower motor is 40% more efficient over standard motors, and as its direct drive, eliminates belts and pulleys and reduces maintenance. It also facilitates ease of adjustment of CFM and static pressure on startup by the startup technician using the programmer display. For optional features on the unit, we have a smoke detector located on the underside of the electrical. There is a leak detector ribbon sensor that is wired up to here, surrounds the perimeter of the unit. This unit does not have a condensate pump, although if there would one, the drain would come from the coil to the humidifier, and then there would be a joint drain from the humidifier to the condensate pump. In this case, we're hard piped to a floor drain. Also, 3-phase electric reheat and steam canister humidification are options provided on this unit. Now we'll move to the high voltage side of the electrical panel and talk about some of the components. We have our non-fuse disconnect switch. We have our control transformer for the control circuit. We have contactors for the compressor, for the fan, for the humidifier, and for the electric reheat. And finally, in line here, we have the selector switch for control voltage. This is a 208 230 volt unit, and to allow precise control on the control circuit voltage, we actually select the exact incoming voltage. Then we have our overload relays for the compressor, fan, humidifier, and electric reheat. And finally, at the top, we have our fan pressure switch and our dirty filter pressure switch. Behind this internal panel is an additional electrical box allowing single point power connection to the power feed to the unit. The electrical contractor would bring his conduit in, connect to the single point power terminal strip. The remainder of the unit is wired internally to the electrical panel. Now moving down to the machinery compartment, we have a highly efficient scroll compressor, 304 stainless steel heat exchanger, brazed plate with the receiver, the head pressure control valve for the flooded receiver, filter dryer, sight glass, and electronic expansion valve. We also have high pressure switch with manual reset and a low pressure switch for loss of refrigerant. On this side of the compartment, behind the steam canister humidifier, is our three-way valve. The three-way valve, when temperature is appropriate, would divert flow to the interlaced economizing coil above. There is always flow through the unit maintained through the condenser. On larger units with multiple compressors, we would have 2 compressors on a single circuit. Larger units, still 2 compressors on multiple circuits, or up to 4 compressors on 2 circuits. The 4 compressors allows staging of 25, 50, 75, and 100% capacity for the unit. Representing a typical glycol heat rejection loop, we have our indoor energy saving unit, a dual pump package, and an outdoor dry cooler for the heat rejection. On this system, where this is an energy saving unit and has the ability to do economization, we have 4 wires coming out to the dry cooler. 2 of them are the run signal. The other 2 would be the temperature signal, comparative, so that whenever the return air temperature in the outdoor ambient had a 16 degree or greater difference, the dry cooler would default to winter mode. At that point, an indoor temperature sensor comparative signal would measure that the glycol was sufficiently cold enough to divert flow to the economizer coil. At that point, the unit has the ability to do either partial or full economization. Partial economization supplemented with the DX compressorized cooling.